Hello all, welcome to my YouTube channel. I'm Kaushik once again. Today we will show you how to compute inverse matrix using the reduced row epsilon form. And it's important to know this thing because in my some of the class, I think inverse matrix class, I showed you some example actually if you follow me properly. But here I mainly showed like how mathematically you're solving these things and how you are using the deterministics of A and all these things. But when you have 3 by 3 matrix, 4 by 4 matrix, this process will not be easy. It will be difficult because here we can solve it because we have only 4 equations. That's why we are able to solve it like this. When you have a bigger matrix, it's not easy to solve like this way. So that's why today we will show you how you can solve or how you can compute the inverse matrix using the reduced row epsilon form. Now remember a couple of points which I already mentioned, that not all the matrix will have an inverse matrix. So first point is that not all matrix will have inverse matrix. This is a very critical point actually. Don't think that all the matrix will have an inverse matrix. Not all matrix will have inverse matrix. Then the another important rule is, if the matrix has an inverse matrix, then what does it mean? That if your product should be a identity matrix. Okay. So let's just first show you one example with and another thing, this matrix has to be a square matrix. Okay, so first let me show you one example with a 2 by 2 matrix, and then I will show you example with a 3 by 3 matrix. Let's consider we have a matrix probably like this. Okay, and what the general guideline to solve this problem is basically create an augmented matrix as a step 1 using the identity matrix. So in this case, if you just put the identity matrix here, so this will be your augmented matrix. So this is your step 1. Once you are up to this step 1, then your next focus is use the technique of reduced row epsilon form. This is basically your second step. And what we can do easily, that is basically, if you okay, let's start from the beginning actually. Okay, so the first step here, after this we just use different color. Okay, so the first thing what we are doing, we are basically we are building the row 1 using row 1 minus row 2. So how it will look like then? It will be 1 because 4 minus 3, 3 minus 1, 1 minus 1, and this is still same. Okay, after this we can do basically the row 2 minus, because 3 we have to make it 0, right? So we have to do it this way. So R2 now come as R2 minus 3R1. Okay, so what will happen? It will be 1 1 1 minus 1 because there will be no change, but this one will be now 0, and this will be minus 1 minus 3, and this will be 4. Okay, But now we have to do the next step. So the next step will be basically, because we need to make sure that this is coming as 0, right? We have to make sure that this is coming 0, because any pivot elements on top of whatever values are there, that should be 0. Okay, so we have to make sure that. So for that, we can again calculate R1 row, and that is R1 plus R2 simply give us 1, 0, minus 2, and 3, and then this row there will be no change, so minus 3, 4. Okay, so I think up to this it's clear. Okay, so next, now we kind of got the whatever the intention actually for reduced row, right? So this is we just use the color. So we got our pivot element is 0, this is 0, so we got this, but we have to make sure this is coming as 1 also, right? That is also important factor. Okay, otherwise it's not uh, the actual form of this reduced row echelon form. Okay, so let me go back to the original color. So from this we have to do one more step. Why my color is not changing on the pen? Okay, so here we have to go one more step, so probably I'll just write it here so that it will be on the same page. So now what we'll do, we'll do R2, because again we have to adjust R2, and we will just multiply it minus 1 with the R2. If we do that, then finally it will come 1, 0, minus 2, 3, 4, and 0, 1, 3, and minus 4. And this is basically the final answer. We got the form, we got the actual form of these things, right? So we got the reduced row. Here we have 0, here we have 0, and these elements are all 1. So it's all satisfying my reduced row epsilon form. And at the same time, this part is my inverse matrix. So this part is my inverse matrix. So what is that value? Is actually, that value is minus 2, 3, 4. Oops, sorry. Let me erase it. And let me go back to the red pen only. So this will be 3 minus 4. This is my inverse matrix. So that's the way, using this reduced row epsilon form, we can easily find out the matrix, inverse matrix of any of the matrix, if the inverse matrix is definitely available or not, based on that. But that's the main concept, and along with that I will show you now the same example but on a 3 by, because this is actually a 2 by 2 dimensional matrix. We just do one more assignment where we'll show that